We will see generalized integration by parts rule. It is derived from our regular integration by parts rule, and it is quite useful in the integrations where we have involved sine and cosines and exponential functions with multiplied by some polynomials. So let's state first integration by parts rule. So integration by parts, it states that if f of x and g of x are functions of real variables, then with certain condition that we are not going to bother, integration of f of x into g of x dx is equal to f of x into integral g of x dx minus integration of f dash x into integral g of x dx the whole dx. Or generally some like to write down first into second, integral of first into second is equal to first into integral of second minus integral of differential of first into integral of second. So some like to write down in this way. So now we will be focusing on integration, generalized integration by parts rule. So what it says, if u and v are functions of say variable x or functions of x, then integral of uv dx is equal to u v1 plus u dash v2 plus u double dash v3 plus u triple dash v4 and so on. So where u dash means d by dx of u, similarly u double dash means d square by dx square of u and so on, and v1 means integral v dx, v2 means integral v1 dx, or which is integral of integral v dx the whole dx, and so on and so on. So we will write down one problem and we will solve using the integration by generalized integration by parts rule. So consider this problem. So consider this as an example. So here we generally use this integration by parts rule when the second function is either sine or in general I should say trigonometry, any trigonometric function, or mostly sine and cosine and exponential. So we go for this route, and ahead of it we have a polynomial. So how to solve this? Let's call this as integral I. So I is equal to integral t square e to the power 2t dt. Again we need to use Eilert rule. Notice that there is no inverse trigonometric function, no logarithmic function. A stands for algebraic, and which is our polynomial. So this will be our first function and this will be our second function, or here we are calling first function as u and second function of v. So I will just copy this and I will use this result in generalized integration by part to solve this. So this will be equal to first, that is t square, into integral of second function. Here integral of e to the power 2t is e to the power 2t divided by 2. Then u dash, so differentiation of t square, which is 2t. v2, notice that v2 was integral v1 dx, and we have already calculated this as v1. So this was our v1. So again, integrating this quantity, we will get e to the power 2t divided by 2 into, again by the integration this 2 will come into the denominator, so they will become 4. And again, u double dash is differential of this quantity, which is 2, and v3 is integral of the second quantity, which is this one. So it will be e to the power 2t divided by 8. And again, differential of this quantity for v triple dash, differential of 2 is 0, so after that everything will be 0. So here our differentiation or integration terminate. So we need to add the constant of integration here. So the final solution can be written down as, we will just cancel out the terms, or we can take 1 by 4 common. So it will be 2t square e to the power 2t, plus here again 2 will remain, 2t e to the power 2t. We should have taken e to the power 2t also common. So e to the power 2t, and this constant of integration plus c.